Okay, so what's the right pronunciation? How do I make sure I get this right going forward?
You did it. The third one, Kodo.
Kodo. Okay, makes sense. Code, source code. Got it. Awesome. Well, thanks so much for joining us to teach us about what you've been working on here. And I'm going to give you the stage so you can get right to teaching us about what this whole notion of flow engineering is.
Yeah, my pleasure. So by the way, yes, it's also about quality code. That's one of the reasons for Kodo. But actually, Kodo mostly stands for quality of development. I can share a bit about my background and how we came to that name. And by the way, Codium AI, now we call only our models, like basically how we see it, like Codium is the base of code. And for example, the LLM, that's what they understand. They understand lines of code pretty well, but not the entire software development workflow. And that's what we are trying to do at Kodo, enabling developers to exploit AI also for code review, code testing, and generally increasing the quality of development. So that's a lot behind the renaming. But I'm not here to talk about Kodo at all. I'm here to talk about the idea of, like you mentioned, moving from prompt engineering to flow engineering, what you can gain by doing that. By the way, I'm not going to talk about the technicalities on what are the, for example, framework that you can use in order to do that. There are quite a few these days. For example, LangGraph is one of them. Rather more about philosophy and motivation and what you can benefit by shifting from prompt engineering to flow engineering. I'm also going to talk about LLMs, just very basic, although I think everybody here know about them. Just in order to create some mutual context, and then talk about a framework of thinking and use that to observe some of the latest models like O1 and Sonnet 3.5. And then obviously, that's what we came to talk about is AlphaCodium, is the framework that released by Kodo almost a year ago, a bit less, like early 2024. It's open sourced tool with which you can win coding competition, get a master level, 95 percentile of the competitors with this tool. We just released like a month ago an update that works together with O1, and then I'm going to elaborate about that. So first about LLMs, if we take a block of LLM just as a black box, like we mentioned, you get an input as a natural language description or code, and the output, for example, is generated code as an example. And this block, this statistical creature, was trained with, for example, a big bunch of open source repos, hopefully in many cases, or permissive data, etc. And inside it, it has a block in charge of tokenization, like taking the natural language description or the code and tokenizing it into vectors, because that's how LLMs know, the best how they work with vectors. By the way, it's also in the entrance and at the output, taking the vector back to code. And inside, we're learning patterns. So that's important. That it's in charge is learning patterns. So basically, it's so critical what's coming in, what's the pattern on which it was trained. That's what's going to influence what you're going to have in the output. So that's so basic concept that we must understand, that basically all it does is match what's the right pattern for the input and the data. Great. And that's bring us to the limitation of LLMs. Like if you use them as is, like a black box, it's hard for them to handle complex challenges. They overfit to patterns. That's what they do, by the way. Okay, they're supposed to fit to patterns, but basically, in many cases, like they're giving you the average for a certain input, and not necessarily considering all edge cases or everything that you would want to consider if you did not provide it as part of the context. Okay, so overfitting for 1 second. 1 second. Sorry. And so and another thing is like maintaining code consistency. Like you cannot expect the LLM to do it for you. Just having the same code consistency. If you had the same piece of code and somewhere around your code base, and you're asking for the same thing, then it would not know how to maintain it consistently unless you had like a product around it, like a solution around it, asking for it. So that's like a third limitation, and the fourth one is handling errors and debugging. So again, here is like, think about the patterns. If you give it a limited context and it doesn't get like all it needs in order to understand how to debug, what to debug, how to handle, it will not do it by itself. Okay, so that's it. Now, with like right now, like a lot of the limitation that I talked about is around like missing context. But what I didn't talk about is also how hard it is to actually do these, like overcome these four limitation without the capability to reason. So like us people, we, even if we collect a lot of context, the relevant context, we still need to reason in order to overcome these challenges. And that was actually another blocker that we had until recently. We might still have it, but we actually got a couple of new exciting models that are doing much better than before. I know that there is a lot of amazing new tools that were released recently. For example, I'm really excited to be the one that's talking after Eric, the CEO of Ball.new. I just recorded a podcast with him. It's coming out like in 10 days at the Latin Space podcast. And like, I think like one of the main reasons that these tools are working now and they could not work around like, let's say 12 months ago, is because these models that we saw recently are becoming extremely good. For example, in understanding like snippet of code and also being able to reason on it in a reasonable level. Now, specifically, OpenAI took it one step further, and they said that O1 model is actually unlocking System 2 capability. And what do they mean by that is something that I want to discuss next. And I'm going to claim that they kind of exaggerated. Okay, it's I think that by the end of this talk, and I'll leave time for Q&A, obviously, we will see that we have more to achieve in order to unlock System 2. Okay, so that's what we're going to talk about. So what is System 1, System 2, and I'm adding System 1.5. First, let's talk about the origin of this terminology. So Daniel Kahneman, like a Nobel Prize winner, unfortunately, like passed away last year. He built a framework, and you can read about it in Thinking Fast to Slow. That's the best place to read about it, in my opinion. Where like trying to split how humans think into two type of system. One is like very fast, reactive to outputs, almost heuristic, like almost using our automatic response. For example, how we behave after we started to drive for a while, like after, in the early days, if you remember when you're driving, you were really, really focused. And maybe after 10 years, it's almost automatic. And then System 2 is more analytical, methodical, slow decision-making. It's more for complex problem. It's kind of autonomous in a way, autonomous-ish in a way that it's like you are not, right now, what I'm doing right now, I'm doing, for example, System 1, I'm kind of giving the next context, next what I'm claiming that what I'm doing now is doing System 1, maybe 1.5, we're going to talk about it. I'm basically, according to my previous tokens, I'm providing the next tokens, okay? And that's like very autonomic, right? But also System 2, despite being a slow thinker, etc., it's still trying to navigate automatically within the environment in order not to just provide the next token, but actually complete a task or complete a full decision making. So that's a big difference. Now, what we saw with O1 model is basically kind of a chain of thought process. It's like not only thinking about the next few tokens, but actually thinking if the model should further think harder on the next few tokens. Should it think on a couple of tokens that make sense to think about? And then if it didn't reach to the final conclusion, to keep thinking another iteration. I don't think that's system two thinking at all, and I'm going to elaborate it. I don't think, for example, that this model is environment aware. If it doesn't get enough context, it won't necessarily understand that it's missing context, etc. While we human, if you're thinking about yourself when you're trying to solve a code problem, like not necessarily writing more lines of code, but solving like a full feature, one of the things that you're doing is trying to realize if you have enough information, what you're trying to understand the tools you're going to use, etc. It's not being done on the fly, for example, and with O1 model. Okay, so I want to actually double down on that because that's important. I'm going to show you like a really high level architecture of a Gen AI system. Okay, some of you might say, okay, I'm now losing confidence in Itamar because he's showing the most trivial solution out there. It's like an input and then like just gathering context and prompting a model and there is an output. But notice something like extremely important, that there is like a field on the input and there is a field on the output. It's not like a very specific like definition of what we're trying to achieve and a very specific output. And that's what's unique in many of the Gen AI system. Like the prompt is not well defined, the context not well defined, and the output could be very vague. I think it's very clear when you're talking about, for example, image generation. Make me a porcupine riding a llama with a moon behind, and you won't care too much, right, on the output. Like you want it to be high quality, but there's not a one composition that fits them all. Okay, and you'll still accept that, and that's why we're so excited about this like models and system that are system one is good enough. When you're trying to think about system 1.5, for example, what we're seeing with O1. Or you can combine your own by yourself. We're going to see that with AlphaCodium. You're trying to chain a few inferences and also use tools. At this point, you can try to steer. The system to also try to clarify what is the input, and also by that trying to be more specific on the output. If I go back to the request of porcupine riding a llama, whatever, a system 1.5 can say, hey, there's 3 different compositions. There could be more, but I'm just giving an example. Would you like it like this or like that, right? And it could be like a chain of thought to try to understand what's appealing, for example, for the user. So that's system 1.5 thinking. When you're talking about system 2, it's more than that. It's an agent. You could consider like as a buzzword, but what I'm trying to say that it's a creature or a machine that is trying to consider the environment that's around him with additional information and tools, maybe considering other agents and considering the overall known and unknown in the system. It's aware that it's part of a bigger system, and it's trying to apply frameworks of thinking. Like Daniel Kahneman says, like when you're trying to deal with like quite a big problem, an important one, you, for example, try to understand what's the environment, what are your goals, what is available to you, etc. That will be like a system 2 thinking. By the way, I'm not saying that we can't get there. I actually think we could and should, but I don't think that's the case with O1. And let's try to give some evidence. So we're going to look at code forces, code contests, together with that's like one of the most prominent like coding competition that you can find out there. You can go Google it, code forces, and specifically DeepMind collected like a few contests into a benchmark called code contest. What we did at AlphaCodium is competed on this code contest automatically, together with a great like competitors like DeepMind and OpenAI and Meta and Salesforce. And I think we're kind of the 5th. We saw Stita Academy also competing there. And I think like what I want to tell you is that with O1, and I'm going to show you results, we're seeing like an inching closer to system 2 than what we have in system 1. We do see in O1 like kind of a guided thinking, like a chain of thought, as I mentioned. We see like some kind of a reasoning. We do see like that it's like taking like a well-structured problem and managing to reason on it. I might show you, if we have time, like an example of one of these. There's still obviously hallucinations that is going on there, and we see like people talking about it. I saw a very cool meme where you see like someone riding a skateboard and crashing. That's hallucination of GPT-4o, and then the same skater managing to jump over a few steps, doing some loops, but then crashing again. And that's sometimes how you feel when you use O1. It's like does a few step. It looks good. It's reasoning on the problem, but eventually still hallucinating. So we are inching closer, and we do see like less hallucination, but sometimes they're really magnificent hallucination instead of like a simple one. Okay, so what did we do with AlphaCodium? In AlphaCodium, we said, hey, in all these like cases where other competitors are trying, like other companies are trying to compete on a code contest, what they're basically doing is trying to force the model itself to move from system 1 to system 1.5 thinking, or they tried in system 2, but we're claiming that they managed to system 1.5. And what we're trying to do is say, hey, with all the respect, we humans are the system 2 thinkers, and the model are not that good in that yet. So let's put a framework of how a developer would solve this. We call it a flow. And then with each node in the flow, let's have an LLM like solve the problem. So what you can see here on the screen is our attempt at Codo to develop a flow where that tries to actually try to do the same exact step that we as developer would try to tackle a problem in the coding competition. So it starts from taking the problem, and there's a few tests, by the way, the problem coming with a couple, sometimes 0, sometimes 5 tests, and then it reflects on the problem like you would do. You try to understand what did you actually read. And then you take a look on the few tests that you're giving, and you're trying to reason on them as well. Oh, that's what the problem actually meant. And then you're trying to think of different solutions you want to come up with, right? Let's write, for example, 4 pseudocode ideas on how I'm going to solve the solution. And then you're ranking, like, what do I want to start with? Which one is the best? Then you might, if you're trying to do like kind of TDD, then you might want to try to generate a few more tests, like create manually. And that's what our system is trying to do. And then you're going to finally write down the program. You're going to run the test on them, and you're going to see if the program actually works. If it does, let's keep on working on the tests that are ground truth that we're giving as part of the problem, and then iterate over the tests that were actually generated by AI, by AlphaCodium, until finally you reach the solution. I don't see the chat right now, but you can write there and tell me. I'll soon stop sharing if this is how you would tackle the problem, but that's how we thought to tackle it. And interestingly, that by building this flow, we gained a lot of other things, other good properties that we didn't think about. For example, the fact that each prompt in each node, in each one of those steps, is actually smaller. It's like, or maybe say like it's less. The variance of changing a word or adding a line or removing a line from a prompt actually is small. The models are less sensitive to a certain word that was selected. That actually, when you trying to do direct prompting, like just prompt engineering, it could be very, very sensitive. But when you broke the problem into many blocks, in this case supposedly 10, actually there's 12, so we're trying to simplify here, then actually the prompt matters less. And that was important. We spent 25% of our time on engineering this flow and only 5% on the prompt engineering itself, because it mattered less. And interestingly, also, it was less important what exact model we were trying. We tried with DeepSeek, actually the old model, not maybe the newest 3.5, Sonnet 3.5. I think this is not the latest Sonnet 3.5, but the one before. turbo GPT, and we noticed that we didn't need to change the prompt so much. So that's like one of the takeaway I want to tell you from today, that if you are leaving the O1 model to do all the thinking by itself, first you're going to be very dependent on the model and very dependent on the prompt. And if you design your workflow yourself, you can be less prompt let's say sensitive, and then like the prompt is also being simplified. What you see here on the x-axis are different models, and on the y-axis is the accuracy on the coding contest. Just to let you know, reaching around 78% like accuracy, solving 78% of the problem is 95 percentile among professional developers, or sorry, among developers that are competing on the coding contest. What you see here, that the purple is using a certain model with AlphaCodium and competing with roughly the same amount of inference calls, like computation efforts, when doing direct prompting. By the way, direct prompting is usually when we really worked hard to bring a good prompt. What's interesting here is that we do see, for example, O1 excel over GPT-4o. By the way, like being double in accuracy is much more than double of problem solving in the real world, because actually the problems, obviously, if GPT-4o solved 23% of the problem, it solved the easier parts, okay? And then if it like the higher you go, like the 78 percentile, for example, you're seeing on the right, sorry, 78% accuracy versus 55, it's more than 50% better. It's like much better because it's dealing with like another 23% of problems that are really, really hard. Just to let you know, we didn't get access, or we didn't ask for it, to be frank, but for O1, the regular one, or O1 IOY, it's O1 IOY is actually a model trained by OpenAI to specifically fit for this coding contest and Olympic math Olympiad, and competition. And actually, what's interesting, if you use O1 preview with AlphaCodium, it reaches higher results than the best model that was actually fine-tuned, for this problem. This shows like it makes it, for me, like a strong evidence that these models are not system 2, because what do we have here in AlphaCodium? Not much, right? Like they could supposedly come up with this framework themselves. So if they're not able to think through to build this kind of processes, then obviously they're not system 2. That's what one of the evidence that I'm bringing here. I didn't dive into each one of those modules as part. I'm going like to show like only one, which is the testing, which is the hardest part and maybe the most critical one. So I'm going to do that via visualization. Let's say that we're taking one problem in the competition. That's the purple. Let's say we're taking one problem in the competition, and an oracle give us the correct solution. And let's say like we visualize it as this like purple a cloud on the left. Now, what happens when you give like the problem, even including like everything you can, the best context, and provide it to a direct prompt, even O1, it will try to bring the best solution it can. It might be very appealing and looks like it works, but maybe there's some skew, like just visually, like trying to explain this. And there's a good reason, because there's like not enough understanding and slow thinking and usage of tools, etc. That we're going to talk about that is done with direct prompting and models that are only using AI analysis. Okay, and now in the middle, what we're seeing here is, what if we like provide a few tests? For example, maybe they were given a part of the coding contest, and we prompt the model to make sure that the test would pass, that it works well for the test. By the way, in this case, you can either, for example, do direct prompting or half of AlphaCodium. Let's say all the green part on the left, that is without running the code and testing the code. What we usually get is overfitting to fit for the public test, that the few tests that we're given. That's in the middle. On the right, what you see here is the attempt to generate additional tests. not only generate like obvious tests, but actually even trying to generate edge cases specifically. This is a hard task. Now, by the way, you can say like, oh, if the model is able to generate tests, why couldn't it generate the right solution to start with? Hey, the model is not that far from how we developers behave. Can you write your code even if you're writing it like perfectly? Sorry, even if you're thinking about it thoroughly, can you write perfect code without tests? In many cases, you would need even sanity tests or whatever, let alone like edge cases to find those cases. But hey, it's the same you that might be writing those edge cases. It's because you apply different processes and maybe even you use different tools to make these. And that's exactly the idea. In AlphaCodium, use specific like maybe different prompting and different tools to generate those tests specifically. And now a shameless plug, that's one of the reasons at Coda we focus so much on test generation. You can see, like, for example, our ID extension called CodaGen has like 3, and more is coming very soon. Stay tuned. More test generation option that they have the specific flows to help you generate those tests. And when we have other tools, we have like a multi-agent platform, and CodaGen and the ID is one of them. And that's what we specialize in. And we have a lot more, by the way, to develop. It's not perfect, but actually you could claim that if you solve testing, you solved software development, right? And that's what you can see here. If we are able to properly generate tests, and then you can actually also generate better solutions, okay? And I'm not going to dive deep in how to choose tests and how to check if they're wrong, because if they're wrong, they could steer the AlphaCodium, for example, to get bad results. By the way, the tool is fully open source. You can read there. I want to tell you one last slide before we go to question, that Meta also did an attempt, their research, to take a model, and actually they did something really awesome. They trained the model on data that is coming from execution of code. So like they did it with reinforcement learning. They kind of trying to teach the model to consider data that is happening here in AlphaCodium. Like if the model output a solution with a certain code, and there was an attempt to run a test, and a test was failing, then that's a negative reinforcement for the model. And if the test passed, then it's a positive reinforcement. And also they can use the errors or the logs. So that's really, really cool idea. And it actually does help. Like, for example, if you check like their solution, it actually does better, for example, with AlphaCode, with not the best model out there. But the thing is that I am willing to bet on really high amount of Teslas that if you take their models and put it in AlphaCodium and run them both one against each other, even considering the same amount of computation, AlphaCodium would do better, because still these model are not yet really system 2 thinkers and not that good. And even I don't believe like we nail it with system 1.5. So AlphaCodium 01, for example, is so high above this this figure. By the way, they use their AlphaCodium from the first release, not the latest one. So that's why they got these results. Great. So that's it. My takeaway for you guys is for everyone at home is, hey, prompt engineering is cool, but also quite challenging. Every word matters. Try to use these models like O1, etc. They reason much better. But at the same time, if you know how you would solve that problem, see if you can generate a graph, a flow. Okay, and for example, using LangGraph as an example, and then you would notice that your accuracy is better. You can put guardrails along the way. You can help the models use tools, and then the reasoning capabilities that we see, they're actually gonna help you get better results. Because even with one node within the flow, probably reasoning capabilities is important. But don't trust the reasoning capabilities of the models these days to do for you the entire system 2 thinking or so.
Awesome. Thank you so much. It's been fascinating to see kind of you share a bunch of the data here. It's actually great timing on the sessions, by the way, because Dimitri, who's coming up next, will be showing a project that lets you actually set up and wire up all of these flows so you can quickly kind of experiment with this in different ways. And it was interesting to see that, you know, O1 and the like of like, I hadn't thought about baking some of these pieces, you know, of reasoning into the model itself, and have been more involved in doing the metacognition on the outside and the intuition on the inside. And so it's kind of fun to see now both evolving at the same time. So thanks so much for showing that. So we have some questions that we'd love to get to here. Let's get to this first one, because it's just asking based on something you were kind of just talking about near the end there.
Hey, Mike.
So, yeah.
Yeah. Okay. Yes. It's. I would say that it's either doing TDD or doing BDD to some extent. Like basically, there are three components that I think we have. Three type of files, meta file that we're using when we're doing software development. We have the specifications, right? Like for example, they can appear in Figma. I would call that specification. We have the code, and we have the test. These are the three types. Some people would consider TDD to be start with the tests, right? And then maybe do the specification in code or only the code, etc. So I think like what's happening right here in AlphaCodium is actually we start with the spec. For example, there is an iteration that tries to understand the problem, and then from the spec we're moving to the tests, and then from the tests we're moving to the code. And actually, I think this is a very plausible way to think of how the future of software development look like. Although I think that life is hard, and in many cases, and basically we developers would love to have all options open to us. Sometimes I want to start with the test because I want to make sure that this is what I want to make sure that it's working. And then I want the AI to help me to do spec and then code. Sometimes I want to start with a test to do code and then spec. Sometimes I want to spec to code. So I believe that you will see different solution coming with different direction, and some solution will enable you all the directions. Specifically at Codo, we believe that fortunately and unfortunately, different type of software development would benefit from different directions. Specifically for coding contests, you want to solve the problem. So you're starting with analyzing the problem that you're trying to solve. You got that, and anyway, the spec. And then, yeah, let's move that to testing and then moving to code. So TDD, like if I have to choose yes or no, the answer is yes. But actually, I think it's more like a spec DD or BDD or business DD.
Got it. Yaniv is asking, how do you evaluate your flows? What made you decide that particular setup was the right flow?
That's a great question. And as I mentioned, we worked like 95% of our time on designing the flow rather on the prompt, because we saw that a good flow requires less time on prompting. First of all, like there is the beginning and the end. Like you have the test that you need to pass. Right. By the way, the really interesting, in my opinion, cool thing about the coding contest competition is that some of the tests that you're measured on are private. We do not see it. You need to submit, so it's harder it's harder for like people. For like really good organizations to try to overfit or to train on that, and what we see with some of the benchmark being like overfitted because the data is out there. And in code contest, the testing data, like there is a test data set that is not given to you. So you use your, like for example, your validation tests that are given by the competition in order to try to generate the flow. So that's the beginning and the end. But I think you ask a really awesome question that can be applied to other. How do we know the middle? Like we can remove one or another, and then like it could help at the end or not. But maybe actually the problem is that we change something in the middle. It actually does create a better result, but the next node just is not the appropriate one to change it. So what I suggest is to putting some kind of your own criteria on nodes in the middle. For example, when you're thinking about, for example, there was one step that is trying to change the problem description into technical problem description. So you can say, hey, I have a few measures on how I want the structure to be like, on, or what do I appreciate? Some of them can be measured like non-statistically, but some of them you can use LLM as judges. So you can take like Gemini, and GPT and Sonnet or whatever, and like tell them, okay, according to this criteria, how good was the output of this node, and then like iterate on that node alone. Some criteria you could put that are not statistically based. I mean, like you don't have to use a model to do that, but for some of them, unfortunately, you need like a technique like using LLM as judges, and it's actually not a bad technique. You need to think about your criteria well, and then it might work quite well.
Got it. Awesome. Thank you so much. We've got a few more questions that we won't be able to get to on the stream, but we'll be able to jump into the Discord. I'm also here thinking about just wanting to chat to you about generating high quality tests and finding edge cases, because so many of the tools just kind of generate somewhat rote, boring, simple tests.
That's the
not
challenge.
Really doing things. So I think I'm so excited that you're focused on the testing space, and looking forward to talking about that. But Itamar, thank you so much for your time. Really appreciate it, and look forward to talking to you soon.
Testing and code review. Review is like also like a very important part of. Thank you, everyone. Really awesome to be here and listen to all others.